Lesson 6, Combined Circuit Elements. Section 6.2, Resistors in Series. A voltage V is applied to the resistors R1 and R2 connected in series, and the current I flows through the circuit. The same voltage V is applied to the resistor Req, and the current IEQ flows through the circuit. If IEQ equals I, then the bottom circuit is called the equivalent circuit. The resistance Req is called the equivalent resistance. The question is, what Req is, when R1 and R2 are given? The voltages across the resistors R1 and R2 are denoted by V1 and V2 respectively. According to Ohm's law, V1 equals R1I, and V2 equals R2I. Kirchhoff's voltage law states that V equals V1 plus V2. By substituting V1 and V2 with R1I and R2I, then V equals R1 plus R2, times I. In the equivalent circuit, V equals Req IEQ. If IEQ equals I, then the equivalent resistance Req is given by R1 plus R2. Here, Req is called the combined resistance. Experiment 6.2. Construct this circuit. Set V equals Vm sin omega t, where Vm equals 3 volts, F equals 10 kHz. Measure VDE, V1 plus 2E, and find the combined resistance R1 plus 2 of the resistors R1 and R2, where VDE is the effective value of VD, and V1 plus 2E is the effective value of V1 plus 2. R1 plus 2 is obtained by V1 plus 2E over IE, where IE is the effective value of I. Confirm that the result R1 plus 2 matches the nominal value of R1 plus R2. In the experimental circuit, the resistor RD is used as a detector to detect the current I. The effective value of the current IE is given by IE equals VDE over RD. The answer to experiment 6.2. Connect the 1 plus pin to the W1 pin, and the 1 minus pin to the point between R2 and RD. This makes channel 1 of oscilloscope measure V1 plus 2. This graph shows the measured waveforms. The orange line is V1 plus 2, and the purple line is VD. The readings of the voltmeter were, VDE equals 0.74 volts, and V1 plus 2E equals 1.5 volts. The current IE is calculated as 0.74 milliamperes. Then, the resistance R1 plus 2 is obtained as 2.0 kilo ohms. Since the nominal values of R1 and R2 are 1 kilo ohms, the result R1 plus 2 was equal to R1 plus R2. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.